Hello and welcome to session 130 in the AISafety.com reading group. Tonight we have Scott Garrabrant from MIRI with us to answer our questions about the Sequence Embedded Agency. Scott, welcome.
Thank you.
Who would like to pose the first question? If no one will take the first question, then I will start with one of the prepared questions. Okay, so the first question that I have prepared is about subsystem alignment and dualism. And what I was wondering about when I read the part about subsystem alignment is that it seems that Alexei, the robot that is kind of like IXI, seems like it might also be vulnerable to the same problems in subsystem alignment. It might, for instance, find a Turing machine that implements a malicious AI while it is working. Do you feel this kind of reasoning is correct?
Yeah, so on these bullets you have here, something about becoming obsessed with a sub-game. I don't think that bullet's correct. Like if you imagine like actually IXI. But I do think that there is a thing where if you have something like IXI where you're just like implementing a bunch of Turing machines, either with some sort of resource bound on the Turing machines or without, you could end up finding solutions to solve certain problems that involve like simulating of agents or like societies or something. It's like if you imagine that like the K complexity of our universe is very small, then you could imagine like one of the easy ways to like get a solution to a problem might pass through a like large simulation of some society or some agent or something like that. This is something I think Paul Christiano has a blog post about the universal prior, like something about what the actual universal prior actually looks like or something like that. Does anybody know what it's called? I'm not sure. There's a blog post by Paul Christiano on like what the universal prior, what like the beliefs that IXI has actually look like. That's about, do you get these kind of agents inside of it? And yeah, I think that's a real thing for that. I want to point out that I think that I'm very concerned about things involved. I'm very concerned about things in the subsystem alignment category, and I think that like the central example from the subsystem alignment category is different from this thing that is demons in the universal prior or whatever Paul says. I think that like the main concern is something different from that, but that's still like important to look at. Right.
Okay. In the meantime, I can see in the chat that some people had found the link to this, but no one had raised their hand for posing questions. So in that case, I will continue to the next question about embedded world models. So we have the question here on the screen. About for example, a tiling agent with some simple tools has to solve the alignment tiling problem, but doesn't have to worry about specialized form of subsystem alignment. Is that true, or are there hidden inner optimizers in these kind of benign seeming tools?
Yeah, I think I got a little distracted by okay. So I think that basically, if you're solving a large task with something that looks like a tool, so let's say you want to, you want to solve some like pretty hard task, maybe some like physics problem or something, some engineering problem, and you like take like a tool sandbox and you have a thing that is kind of only optimizing within this tool sandbox, kind of only doing this like very local optimization, not thinking about the outside world, not doing anything like that. The kind of thing you'd think of a tool as like, that's like a very finite goal. I think that this does have subsystem alignment problems, I think that there's a kind of like convergent instrumental goal, which is being able to like think in a like very general, being able to like think in a very general way about how to like solve whatever problem, think about how to solve problems in general in order to solve whatever problem you're trying to do. So like even if you're trying to solve a very like basic problem, there's an incentive to be able to think about how to like distribute your own attention in order to figure out where to direct attention so that you can like solve a thing. And if you have a system that is like not doing this as well as it could by default, then you have like this incentive for like inside the system to kind of cut across your planned way of solving the problem in order to like be able to reason about these things. If I did not think that there was an inner optimizer problem for tools, then I would probably not be paying very much attention to agent foundations at all. I think that like if the, like you could ask the question like why am I focused on agency? And I think the answer is that I think that agency is convergent. I think that things like agents that are reasoning about how to like distribute themselves and reasoning about like how to do things for a reason are like a like necessary sub piece for the easiest ways to solve many problems. And if you're trying to solve a problem in a way that looks like a tool and not like an agent, you're creating an incentive for like agency to show up inside. And like, yeah, if my answer is like not only do I think that it's a problem, but also it's cruxy for me. It's like if I changed my mind on whether or not there would be and whether or not there would be subsystem alignment issues for tools, I would also change my mind about like the necessity of a lot of the stuff that I'm thinking about.
Okay. I can't see any questions from Robert Miles have raised your hand. Do you have a question, Robert?
Yeah. Well, I was just wondering if it's been, if there are any examples of, sort of concrete examples of how this might happen, where we have a well-specified tool and agency emerges from it. Because it seems like plausible to me intuitively, but I also would be interested to actually watch it happen in a toy situation.
Yeah. I don't think that we have a lot. I don't think that we have examples now. I don't strongly feel like we won't have examples until things are super intelligent. Like I think that there's a potential for getting examples like this. But I think that like right now we do not have many examples.
And like actually implemented, it could be, you know, something like agency where it's just well specified enough that we can see that it happens.
Yeah. Yeah, I want to say something like, if you imagine, so the like canonical example, which I like and a lot of people don't like, is evolution. So I mean, there are lots of reasons to think that evolution is maybe not the best example for trying to figure out what's going to happen in an AI system, but like you could imagine there's kind of an outer feedback loop in evolution, which is like I need to like learn how to gather food, and as like I come up with better, as like the animal like comes up with better ways to gather food or something, the outer feedback loop can like reward or punish being able to do it a certain way. And you can imagine this thing is like being very slow. It's slow and it's working in a like sufficiently rich environment that it has the potential to kind of like short circuit the like outer feedback loop that's happening. So you have an outer feedback loop which is saying like, okay, let's like gather food or something. And then there's kind of an economic incentive for there to be a shorter feedback loop which necessarily works using a proxy, which is like what the humans are doing. So like the human brain is a shorter feedback loop than cycles of evolution. And it manages to be a shorter feedback loop in part because it is not like directly working on the thing that evolution wanted to work on, which is genetic fitness, but working on like more simple things, possibly like hunger. And if the outer system is like designed in a way such that there's a more efficient way to do it, and it's designed in such a way that like if there is a more efficient way to do it, it would like find that way, then you end up with like the outer system starting to depend on a like more economically viable inner system that's able to like solve the problems for it.
Right.
So
that makes a lot of sense. Thank you.
Okay. If that answered the question, if I can just make a quick, if people who are not speaking could mute their microphones, I can hear a bit of background noise. I would appreciate that. Ali, you have a question?
Yes, I have a question. I can't remember if we resolved this in our reading group, but I remember we were pretty confused. In the section about Vinnian reflection, I think you said that if you added uncertainty to counterfactuals, then say you have 95% of something happening one way and 5% of the time it proceeds a different way. You said 90%, 5% of the time you would get the same result as purely deterministic counterfactuals. And I was wondering what you mean by 95% of the time you have the same result.
Yeah. So that's kind of a response. Like when we say, like, if you know what you're going to do, then you can't, like, make the other counterfactual. And then people sometimes, like, give a response that's shaped like, well, you don't actually, like, know what you're going to do. You don't actually, like, know your real source code. Even if you, like, see your source code, you have, like, some probability of, like, it being some other source code or something like that. And I think that's not getting at an answer to the real problem. So I guess I'm saying something like, let's say I'm in a 5 and 10 problem, and I like believe with I think the main reason is something like the like cosmic ray thing that was in the decision theory section, where you have a if you're like going off of some like weird obscure like I have some like small piece of uncertainty about what I am, then you get something that does not look like what would happen if I decided to do X because X was the right thing to do. You end up with something that is just like very different and possibly like different in a lot of ways. There's a thing about like probabilistic versions of Loeb's theorem, where if I imagine that like no, I think I don't remember exactly what to say about probabilistic versions of Loeb's theorem. I think there's an old Less Wrong post on this by, I think possibly Stuart Armstrong about probabilistic Loeb. Might have been by Vadim. I'm not sure.
Yeah, I wrote something about probabilistic Loeb, but I don't remember. No, I don't think I did probabilistic Loeb. I did proof length Loeb.
Oh, I thought there was something on probabilistic Loeb. I think that so if I imagine I'm in a situation and like I'm not sure that it's actually a like me in a 5 and 10, I'm like, there's a 95% chance that it's me in a 5 and 10, and like a 5% chance that it's some other random thing, and that some other random thing like has some expected utility. Then I can still kind of say, if I were to take the 5, then I would get a 95% chance of $5 and a 5% chance of this other random thing. And if I were to take the 10, I would get a 5% chance of $0, or 95% chance of $0 and a 5% chance of some other random thing. And you can still kind of like introduce the uncertainty about the problem that you're in does not fix this. Introduce the uncertainty about what agent you are, I think is more like, I think it's more pointing out a problem with trying to do this like expected utility stuff, because now if I have a 5% chance that I'm like a completely different agent, then I'll like jump into that other thing, which in the 5 and 10 problem is like, yeah, if I believe that I'm actually in a 5 and 10 problem and I think, oh, there's a 5% chance that I'm just take 10 bot, then I'll like get the right counterfactuals out of this. But in other problems, I wouldn't necessarily.
Okay. Tim, you also
Thank
have
you.
if that answers the question. Then Tim, you also have a question about counterfactuals and the 5 and 10 problem.
Yes. Okay, so the way I perceive humans thinking about counterfactuals is that we have simplified models of the world and we run simulations on those models to predict the future. We run simulations with some changes like the sun disappearing to form counterfactuals. Is it possible that that's a framework that possible future AIs could use? And well, another thing, an agent would never know it would take the $5 because there's always a chance it could consider a counterfactual that gets it more money, in which case it would switch to that associated action.
Yeah, so there is this thing where like there is a thing that humans are doing when they're like taking counterfactuals that is doing this naive thing, which often just like involves replacing themselves as something else that like takes the action or something and leaving the rest of the world the same, and then like kind of like causally looking at what happens when they do that. I think that there's a reason to expect that this might work well for humans and stop working well when you have a system that is both like more able to see itself and more likely to show up in more than one place at a time. And so like there's kind of a thing that there's kind of there's some reason to expect that like this kind of thing, the reason that humans are able to do it is because it doesn't matter exactly how we write down how we're doing it, because most ways kind of like turn out about the same because you don't run into these edge cases. And I think that a lot of the like I think a lot of the motivation is coming from an expectation that like as you get something that's shaped more like recursive improvement and stuff, you like push into edge cases by like just like extreme values and stuff. Another thing that's not just like, we push into extremes, and because we push into extremes, we get this like edge instantiation where we like get into edge cases. Another thing is that like humans are not like directly reasoning about themselves as much as like I would expect a system that would do very well in the long run to do. Like there's not a lot of incentive to like directly reason about like low level parts of ourselves, because there's not much that we can do to modify low level parts of ourselves in a productive way. And like if that changes, which I expect it might change, then things might break down.
Thanks.
Okay. So no one has raised their hand. Ashwin has a follow-up on inner optimizers.
Yeah, so sorry, it's quite possible I'm just missing something here. But I guess I wanted to clarify a bit on, I agree that I can see how agencies convergent, but it feels like sort of both empirically and maybe abstractly, like clearly there are search processes or just like processes that are not powerful enough to like do the kind of search that would get you to bad inner optimization. So it feels like I guess one way of phrasing this maybe is like, how much is this like an issue in terms of this is something that we expect to crop up a lot for like all kinds of agents versus like it's just bad that we don't know how to think about this properly for just generic like clarifying our reasoning about how agents work reasons.
Yeah. So I want to say something about like, yeah, so there's this question about like inevitability or something. And then there's another question about like how powerful do things have to get before you're going to have this like actually be a problem or something. To the inevitability question, like in evolution, we could have imagined that maybe evolution like proceeded by like avoiding having human like, or avoiding having minds that all pop up, where you could say like, like let's make evolution like make some like better tools, but not have any like maybe you have some very primitive minds, but you like stop minds inside individual pieces from like popping up or something like that, by like maybe like watching over evolution and like performing surgery to make sure that this doesn't happen. And then it becomes then like it's plausible that you like have evolution do this for a long time. But I think that there's certain problems that just, if you look at evolution as it is without the like spinning up of more efficient minds and give it a task like get to the moon, like there was just no way that evolution was going to be able to do that without like at some point deferring. And maybe this is wrong, maybe evolution could have gotten to the moon without like deferring to a smaller mind. I'm not sure how long it would have taken, but there's this thing where you don't just look at the structure of the thing that you're running, you're like looking at the task, which is like the stopping time for running it. And so it might be, there's something like, if you build a system such that if it works the way that you intended, which is like evolution maybe without the minds that it spins up, if it works that way, there's just no way in which it's going to accomplish this task, but then it accomplishes the task anyway, then you have like, then it like must have been because of something like this, like tautologically or something like that. And I think that like a lot of what we're trying to do is we're trying to like scale things up and like point them in at themselves in ways that we're like not fully understanding, in a way that, and trying to solve problems that kind of are too hard for what we're trying to, for the techniques that we're using, if like directly. And there's a sense in which this is how we're doing kind of everything. There's a sense in which like there's a connection between the like inner optimizer problem and like how we're able to do machine learning at all. Like there's a sense in which like the only tool we have is taking something that's like the inner optimizer problem and using exactly that thing, but like in a way that we're expecting it to like not have problems, at least yet, or something like that. I think I went off on a tangent. Can you restate the question?
Sure. Yeah. I mean, I think that's like fairly relevant. I guess the follow-up that I would have to that, which was, I guess, part of what I was asking, was like, it seems though like we have tons of tools where like that are fairly powerful where this doesn't come up because we have like cache knowledge that we developed through various means that like now we can implement in terms of like pretty well specified like dumb tools that just like, you know, are doing complex computations or whatever, but like with a very specified like structure and desired outcome. And so I don't know, it seems feasible to imagine like a like scaled up AI that has, you know, molecular modeling tools or whatever, but like those tools aren't like going to optimize for any particular thing. Like they're just like modeling how molecules form and react.
Yeah, I agree that you can build like a whole bunch of tools without having to like go towards a problem that's like so hard that like given our current understanding of how to solve problems, we would only be able to do it by kind of deferring to something else that we create or something like that. like I agree that there are a lot of problems like that. There's two questions. One is like, well, or maybe just one question. Like, question is like, what do you do then? Like, do you think that, like, if we think we're eventually going to have to solve problems that are hard enough, then there's a question of like, well, can we then use these tools in a way that, can we like then use the tools that we can create to be able to safely reason about how to like solve bigger problems without kind of just using like naive methods or something. And yeah, so well, yeah. One question is like how does that help us? And I think it does help us a lot, but like you actually have to like think about how or something. And the second question is like, how do we know when? Like it might be that we expect it to be late enough that the thing that we should and we expect it to be late enough, and we expect that like things are like this is the best path is to kind of just like push to like harder and harder tasks like very slowly, and then with each new task we then say, okay, now we have a new tool, let's see if we can use this new tool to be able to think more and be able to get like a true understanding of what's going on before we like push to higher tasks. But that like requires some sort of understanding of like what tasks are harder than which and such. And also like that requires like a lot of global coordination to like kind of slow down long enough for us to be able to use these tools before just like moving on to the next thing. And so, yeah. And it
Sorry,
might be
you just crashed for me. Could you repeat the last sentence or two?
The last sentence is that it would require a lot of global coordination to be able to like create new tools, use the new tools in order to like enrich our understanding before like moving on to like creating a like larger tool without understanding what's going on or something. And so like it seems like a plan that might work pretty well, except like coordination's pretty difficult, and there's like an incentive to like yeah.
And you think that applies not only on the level of like building like tools that humans use, but building tools that like an AI would use. So like having an AI that's restricted to using like tools that seem like pretty solidly safe or even provably safe by some method or something like that seems like a significant enough constraint that like there's a strong like racing dynamic where people who don't input those constraints get pretty far ahead.
Yeah, when I imagine like building tools that then we're directly having AIs use as opposed to like building tools for humans, I feel more doomy about it for two reasons. One is like now one is like how does that AI work in the first place if it's like it being agentic about how it's using the tools, and the other one is like now I expect even more that you'll get like runaway feedback loops where like you get a like a smaller gap between being able to build the tool that lets us do some like new fancy philosophy or computer science that lets us like maybe get some stuff that lets us like learn what's going on, and like the opportunity where someone can just like not pay attention to that and destroy the world. I don't see any reason to be more optimistic about making tools that is not passing through human use.
Mm-hmm.
Okay, if that answered the question, we will continue to... Yayan, could you repeat your question, please?
Absolutely, yeah. So my question is this. It appears that logical induction is an example of meaningful deconfusion around questions of logical uncertainty. What confusions still remain at the interface of logic and probability?
There's the main confusion in my head on like the interaction between logic and probability is I think that there's a certain kind of like non-Bayesian about logical induction, non-Bayesianism around logical induction, where like there isn't a way to like kind of separate it out as like a prior and then like a bunch of updates. This does not make me think, oh, so this like creates a confusion. This does not make me think, oh, we have to like find like the next thing that is like actually Bayesian or something. But like, there's a lot of confusion around, like if I enter one frame, there's like all of these reasons why like anything that's not Bayesian is like necessarily not reflectively consistent or something like that. And then but then I like enter another frame, which is like Bayesianism kind of doesn't even really make sense with logic. And so I think one of the biggest confusions, so like one of the biggest confusions for me is like, what's the deal with the fact that it doesn't appear Bayesian? Am I missing something where actually like it's more Bayesian than I think, or am I missing something where like actually like we find something better that appears more Bayesian, or am I missing something that's like actually like it wasn't supposed to be Bayesian all along? And and then this has like downstream consequences that are like largely related to like reflective stability stuff, like in the robust delegation section.
Cool.
Okay, David, you raised your hand.
Yeah. So one of the sections of the sequence, it was the part about making sure that first generation AI will reflect human values. You refer to that as a principal agent problem. And I was wondering if you guys had looked at any of the economic literature on principal agent problems, or if it's just an analogy and you don't think that.
I think it's mostly just an analogy. As a fact about myself, my methods are I do very, very little reading. Other people on my team do a lot more reading. But basically, any question of the form, have you read X? The answer is probably no. So I think that a lot of, I think that like it was an analogy, and also like it is like a very specific subset where like it's not just, oh, we're dealing with principal agent problems. Like we're dealing with like a very specific type of principal agent problem where the like agent is like much more intelligent than the principal. And much more intelligent does not just mean like can solve things in ways that the principal didn't consider. It also means like can like notice the ways in which like the principal was wrong about things and stuff. And I would be surprised if there was a lot of literature that like went into that specific subproblem, but I don't actually know.
Well, there is literature about like individuals contracting with corporations, which I know is not a perfect analogy, but does seem like a somewhat less pure example of the same problem.
Where the corporation is the agent.
Is the agent, yes.
Yeah. Yeah, I think I also like when I think about like trying to read that and trying to figure out if I expect to feel like less confused, I predict no. But I don't know.
Okay.
It does seem like it's probably sufficiently different.
I guess, David, if you have some interesting papers that seem like they could be relevant, if you could pass them along, that would either to me or Scott directly, I guess. That might be a feasible way forward.
Yeah.
I want to flag also, though, that the general strategy of like trying to learn from humans and groups and like weird mathematical models and like all basically like learning from any kind of analogies that we can make is a strategy that in general I am like very pro and want to just point that out.
Okay, I don't think there's anyone who has
well-
raised a hand. David, do you have more, please?
Yeah, just I do wanna reiterate that in like 2 to 3 years I will be looking for a job. So if you want to outsource that work to me, then hit me up.
All right.
Sounds great. So I have another question. Well, there was actually some questions also more about Miri than about embedded agency. I don't know if you are actually the right person to answer these kind of questions.
Probably not.
Probably not.
Right.
So, yeah.
I might just refuse to answer things without even giving a reason. But you can ask me questions.
Okay. One of the questions that were posed before was about Miri's current hiring pipeline. Are there enough people who are applying to Miri? And if not, what seems to be the problems in getting more people on board in Miri, of expanding?
I guess, yeah, I don't know. This is probably not an answer to that question, but I want to say a thing that's like related, which is like workshops and stuff that we run are like a pretty large part of onboarding and like hiring. So it's like very unlikely that we would like hire an individual without having like interacted with them through something like a workshop, possibly multiple times. Like if you're interested in embedded agency type stuff, then like the Miri Summer Fellows Program workshop, which we've run 4 times so far, and I don't know for sure that we're going to run it again, but we likely might run it again, is like probably like the best way to get into that. And also like we run a bunch of workshops for programmers, which is another thing that might be interesting. And I don't actually know where to send you, but I assume that the Miri website like has information about like how to get in contact about those. But like, yeah, I guess the main thing the main point I wanted to say was just like workshops actually are like a very like key part of the pipeline. Like when I think about like getting new people at Miri, when I think about like getting new people to work with, like there's kind of 2 steps. One is like getting good people to like come to workshops, come to like MSFP, and then there's another step which is like trying to like do filtering from that point, which is kind of bad because like it's kind of like costly to, I think MSFP was like almost 3 weeks last time. That might be costly for a lot of people, but like currently, so there's flaws with that, but currently like workshops are a pretty central part of how I'm thinking about who to hire. I don't even remember if that was the question. Yeah. MSFP is Miri Summer Fellows Program. Also called AI Summer Fellows Program some of the years, but it's the same thing.
Okay, I can see that David has... Oh, sorry. I can see that David has raised his hand. Is this more about this topic? Because in that case you can get in ahead of Ali.
No, I think I just forgot to unraise my hand
Fair enough.
earlier.
Ali?
Hi. So, a couple of times I read once that when you try and get an oracle to sort of self-reference or access information about what it did in the past, you'd get some sort of the probabilities become unmeasurable. And I was wondering that since self-reference seems to be at the heart of a bunch of these problems of modeling agents, what do you think you would do if you found out that there's like some non-measurable the probability of agents going through with self-reference? God, sorry, I'm not making any sense. I guess I'm just trying to say is, what would you do if there is no well-defined probability of dealing with most self-reference problems?
Yeah, so this gets back to the like logic and probability question, which like I think that there being like no well-defined probability for these things is basically like saying like the tools that we have that are like probability shaped are like not, or probability or like Bayesianism shaped are like not the right tools for the kind of problems that like involve self-reference. And I would feel like I'd want to like I'd kind of want to like abandon the tool of probability, but I would like most of the time while doing this be like looking for like every possible way in which I could not abandon the tool of probability or something. And I'd want to like at the end of the day understand why it's kind of okay to have abandoned the tool, because right now it feels like there's lots of like good justifiable reasons to say that like everything that's not probability is kind of like wrong or something. Yeah. But it's also possible that like the path forward is to try to abandon any kind of self-reference, but this is like very, very hard. This is like very hard for reasons that are like inner optimization. Like when I said that if I imagine inner optimization was not a problem, then I would like be happy to like do things with just tools and not agents. And I think that like what I meant by like agents there, like a large part of what I mean by agents is like things that are actually doing the self-reference stuff. So it might be that like the solution is to have things only working in a domain where self-reference doesn't matter. Like if I have a thing that's not reasoning about itself and only reasoning about like how to like do the molecular stuff right or something, then like I could imagine just like avoiding the domains in which the thing's wrong, but that feels like very scary to me. Like using a tool which like you understand that it would fail if it was in this other situation, and also you don't understand why it would fail if it was in this other situation, and just like hoping that things stay okay with that is pretty scary.
Thank you.
Okay. So there is no one else in the queue. Then I had a question about the Löbian reference. Let me just see if I can find this here. Which is the Löbian obstacle is mentioned in the part of the sequence about Vingian reflection, about agents that are smarter than you. But I'm a bit confused about whether it's actually the Löbian obstacle obviously happens at around the human level, because humans are smart enough to prove Loeb's theorem. So does it become worse in any appreciable sense once the AIs get above the human level?
Yeah, so the Löbian obstacle, I mean, yeah, the Löbian obstacle for self-trust is basically like saying at least if you use like some sort of axiomatic system for trusting a future self, where the future self is like stronger than you, like able to like know and like deduce strictly more things than you, then you like I don't know, this is like the most literal version. There's lots of like other versions that are like in an analogy with this, but like then you like necessarily are inconsistent, and you can basically prove everything. So one could say like, well, maybe I could like trust my future self, but like also trust that I am like whatever my search for like beliefs or something is weak enough to like not find the argument that like passes through Loeb's theorem. And this just seems like if you're powerful enough to get like any useful stuff out of this, out of like your trust for your future self, then like you're kind of just like already too close. And I think that like I think that if you're going to imagine a system that you think is like weak enough that it's not running, if you imagine a system that is avoiding the Loebian obstacle just because it's like too weak to like be able to reason there's a problem, be able to like realize there's a problem, you're probably, if you're imagining a system that's going to keep a system that weak, you're probably better off not having it reason about itself at all than trying to have something that is reasoning about itself and trusting itself, but like not, yeah. So yeah, if I were to imagine trying to have something that's like weak enough to not have the problem, that just seems harder, more impossible, a worse strategy than trying to have a thing that's not reasoning about itself at all.
To follow on that, I would imagine that almost all current humans are in that category, in that almost all current humans are modeling themselves and thinking about themselves in many different ways, reflecting on themselves, and at the same time most humans are not capable of proving Loeb's theorem, or most humans have never heard about it, of course.
I think that most humans do not have something that looks like an axiomatic self-trust of themselves. Like I was saying axiomatic, and that does actually mean something. I think that like there are ways in which one can learn to trust their future self, kind of by induction. Like I can learn, hey, over the time as I've like grown over time, it's turned out that whenever my future self believed something that my past self didn't believe, my future self was right because my future self could take into account what my past self believed, and I've tended to be more smart over time, and things that I've like learned, like my beliefs have gotten better over time and stuff like that, and I could like learn that fact and like believe that fact without having it be the right form that would like create Loebian obstacle. But yeah.
Okay. I'm still not seeing anybody raising the hand.
Like I guess I'm trying to say that there isn't a short argument that I could give, which is like I'm going to teach this human about Loeb's theorem, and then all of a sudden they're going to start proving bottom all the time. Like, and that's because like they're not working in a system such that, yeah.
Okay. Okay, Chris Cooper has a question.
Yes, thanks. I'm trying to go back to basics on the 5 and 10 problem, which I'm sure I wasn't the only one who got really confused by it. And I'm sorry, by the way, I know we had earlier discussion about it. I'm sorry if what I say was actually answered by that. But anyway, the thing is, we have this stage in the 5 and 10 problem where the agent is if I've got it correctly, it is essentially saying it's considering whether to pick up the $5 or the $10, and it's from the proposition that picking up the $10 would give it either zero value or less value than picking up the $5. This counterfactual leads to it deducing that it's better to pick up the $5 rather than the $10. I've probably completely mangled that just because I don't understand it. But basically, the only way I can make sense of that is that to suppose that this counterfactual of picking up the $10 giving less value is a result that comes from the finite processing ability, the finite computing ability of the agent. Because presumably if it actually had sufficient computing ability, it would never generate this counterfactual. But can you tell me if there's any sense in what I'm saying?
Yeah, so the thing about it coming from finite computing ability is like definitely not the thing that I'm trying to get at. I think that where it's coming from is I'm using a really stupid counterfactual. The counterfactual that I'm using is like material implication. I'm saying that like if X implies Y, then like I'm like willing to accept the counterfactual, like if counterfactually X, then Y, which is a really stupid version of counterfactuals. And like, but it's so it's a really stupid version of counterfactuals. But we really don't have many alternatives. Like we have like one might propose a thing that one might propose is like material implication. This implication is where you get your counterfactuals from, and this is kind of showing that like that doesn't really make sense. And one might also say that like expected utility is where you get your counterfactuals from, or like expectation, like conditioning with like some probability thing is where you get your counterfactuals from. And that also kind of doesn't make sense because you get like division by zero if you like know things about yourself. Like, I think that this was not supposed to be a positive result as much as like a negative result, in the sense of like it's showing that like all of the simple ways that we have for like writing down what counterfactuals are wrong. And I think that the takeaway is that like implication is not like a valid counterfactual, and that it matters where you like how you like try to define your counterfactuals, and that like all of the ones that are really easy to define like are bad, and then we're like, well, now what do we do? And also like counterfactuals are like in a certain sense like unlearnable.
I mean, I sort of, can possibly see that. I mean, you didn't.
But I don't think it's because of resource boundedness at all.
I'm sorry, say again.
But I don't think it's because of resource boundedness at all. I think that it's.
Oh, I see.
It's like equally there with.
Did you?
There are many ways in which unbounded agents get these kind of problems worse.
Right.
Right. Did you devise the 5 and 10 problem yourself, or is that standard in the literature?
I don't actually know the history. Do you know the history, Stuart? It was definitely a thing that people at MIRI talked about long before I was there.
I believe it's Wei Dai who came up with it at a sort of retreat in one of the houses there. I at some point tried to call it the heavy ghost problem because I thought that was much cooler, but 5 and 10 stuck.
Okay, that's a funny anecdote. I guess Jan has the next. Oh, I should probably say we are above the 1 hour mark here. So I guess, Scott, if you need to go somewhere else, then please just say so. Otherwise, I expect we will continue asking questions until the queue of questions is empty, basically. I hope that's okay.
All right, let's keep going at least for now.
Okay, Jan has a question. Jan, could you read out loud your question, please?
Absolutely. The embedded agent sequence mentions ontological crises, but doesn't seem to go into detail. Do you think ontological crises are a significant issue in designing embedded agents? Would solving some other subproblems reduce the challenge of ontological crises?
Yeah. So I think that ontological crises are like. Wait. I think I'm going to say some things related to ontological crises. I might need to hear the question again. But I think ontological crises are like possibly. They seem like pretty likely to be related to how to like do embedded world model stuff, because you have to like start out working in a system that like is like necessarily wrong and be able to like move to another system at some point. And also there's like a similar problem to ontological crises, which is like merging of ontologies, where like maybe I have some beliefs that are in one ontology and some beliefs that are in another ontology, and like how do I like deal with this fact? And these seem important to me. Also, like, you shouldn't update too much on the fact that I mentioned ontological crises at all, because part of what the like embedded agency sequence was like trying to communicate an ontology from which you can kind of like look at all of the past MIRI stuff. And like ontological crises was like an example of a past MIRI stuff, and I kind of just like included everything that kind of fit. But I also think that it's I think it's like important, but in the way in which like I'm naively factoring the problem / thinking about it, I wouldn't have like called it. I'm not sure if it's like cutting things the right way. I don't know. Yeah. Do you want to say a question again now that I ranted?
Sure. Yeah. Thank you. That was helpful. That gave a lot of good like background info. I guess the question was really, you know, do some of these other subproblems in embedded agency relate to ontological crises and are kind of tied into that? And I think you already sort of mentioned like embedded world models. It's possible that robust delegation could be relevant, because if you're delegating to another agency with a different ontology.
Yeah, I think I want to say something like ontological crises. I think maybe ontological crises is the wrong handle. There's just like stuff that deals with what happens when ontologies are wrong, or what happens when there are multiple different ontologies that need to be able to communicate with each other. Like how do you just deal with that problem? And that feels like a cluster of problems that you kind of want to look at all at the same time. And that is a thing that like you'll see across everywhere. Not everywhere, but across like lots of the places. And I agree that like it seems like an important part for robust delegation, because because you have different ontologies in like earlier and later things, and they need to be able to also seems useful for like transparency type things and just communication in general.
Cool, thank you.
Okay, great. I don't think there are any more questions in the queue. Does anyone have any final questions they would like to ask Scott Garrabrant from MIRI? Well, then I would like to say thank you to Scott one more time for coming here and answering our questions. Then I'll basically say see you next week.
Thank you.